This is your last chance. After this, there is no turning back. You take the blue pill and you wake up in your bed and believe whatever you want to believe. You take the red pill and you stay in the wonderland, and I'll show you how deep the rabbit hole goes. Hello and welcome to my channel. I know that many of my viewers wondering how they can start to learn about robotics in a simple way. And most of the time the problem is the hardware. And over here probably we have a solution to this problem. This is a small desktop size robotic arm. It's produced by the company WLKATA and the name of this model is MT4. So WLKATA MT4, it has a precision 0.1 millimeter. It's made out of metal. It has only 4 axes and it has a lot of accessories. You can run it with the ROS, with Arduino and with MATLAB. Over here it seems quite promising. It seems like out of the box you have a lot of stuff with which you can start to learn about robotics. The repeatability 0.1 mm, payload 500 grams, half a kilo, it's okay. 4 degrees of freedom, open source. I wonder if they have the URDF file for this robot arm, but because it's supported in the ROS, most probably they do have the URDF file. And for the software there is a WLKATA Studio and WLKATA Block Factory. We are going to learn what is it. And over here also there are a lot of different video and tutorials. The manual seems quite promising. I like that they put here this warning about laser engraving. Good, let's open the box. Ta-da! This seems like a gripper. The power supply. There is something else over here. This is a control box. The pump module. This is a 2-finger soft gripper. I never used such a gripper, but I always wanted to try them. This is probably a pen holder. Small tools. And now the robot itself. Blocks. Suction cup. This is a nice suction cup because it has a bellow over here. And here there are other different sizes of the suction cups. The smallest one and the biggest. Let's look at the robot arm. So this is a robot arm. There are 2 buttons. Probably one of them is to switch on. Some connectors over here. There are 2 huge NEMA 17 motors, and this is necessary in order to have the good payload. The belt transmission, I really like this because usually belts they have 0 backlash. And for the first axis, it's also belt transmission over there. In every joint there is a bearing. So from mechanical point of view, it looks like really well built robot arm. There is a cable over here, which goes to the end effector of this robot arm. And this cable, it powers the small tiny motor inside. And over here, we see the output shaft of this small tiny motor. The base is quite heavy, so I think for most of the time you don't even need to bolt it to your table. Let's connect this robot arm to the power and to the PC, and for this, according to the quick start guide, we need multifunctional extender box. So the cable goes here, the second side of the cable goes here, the power supply goes over here, USB cable is going in the extender box. The installation is straightforward. First of all, I installed the required driver and afterwards WLKATA Studio. The power to the robot arm. Oh, no explosion. Now the USB goes to the Windows PC where we're going to run this WLKATA Studio which we just installed. First of all, we need to be sure that we connected the proper device, MT4, and it's connected. As far as I understand, the first thing to do is the homing. So let's try to do the homing. Probably it's going to move the robot arm. This robot arm is quite silent. Nice! Now there is here joint mode and there is a coordinate mode. So in the joint mode, this probably is the joints. Yes, these are the joints. The second joint, the third joint, the fourth joint. And here we can change the speed and steps. Perfect! And let's go to the coordinate mode. So here X, Y, Z and rotation. X, Y, Z. And if I will go to the joint mode, we see the joints which corresponds to these coordinates. And here apparently it's a command which is sent to the robot. So probably this is a G-code command. Nice. So there is a teaching. So probably here I can save different points and go through these points. Blockly. Everyone knows Blockly. Drawing. Python code. G-code. Seems like a quite straightforward program. So there is a notches over here, which shows that this joint is properly homed. It's difficult to see, but there is a notch over here, which also well aligned. And the axis 3 is underneath over here. Now let's try the teaching mode in the WLKATA Studio. Now we go to the teaching mode. And I suppose that over here we can go to the certain position and afterwards save this position. Okay, this is the first point. So here's the add to add the point. The next point is going to be, let's save this point. Now let's open and let's go down. Save this point. In the same way, I added several other points. And afterwards, I defined the trigger for each point. So I put either inhale, blow, or power off. So for some reason, it does not account these values. Okay, now let's run it. We can say that this is success. The motors are slightly warm. Nothing to worry. Perfect. Power off. And now I would like to try this gripper. So it only can hold something quite big unless it should hold it over here. So probably it can grab the two cubes together like this. As usual, first we do the homing. Over here there is a gripper, servo gripper. And we can try to open it. Close it. And power it off. Let's try to grab the two cubes. Gripper open. Close the gripper. Goes up. Successfully. And open gripper. Perfect. It works. This robot also can draw. Let's try this. So over here I put this star, which you can choose from this list, but also you can draw with the pen. We need to set the pen position, so the height of the pen. This was too much. This should be the proper pen height, so set pen height. And now let's draw. I think it was not a good idea to fix the pen so high, but nevertheless it works. Also, this table has some texture which does not help at all. I have installed the suction cup in order to test the Python module. Here's a Python program. It's quite simple one. And now let's run it. and check how precisely it put it back, this cube, like exactly how it was before. Let me run this program in the loop just to see if it will manage to do this multiple times. Like this we can check the repeatability. If the repeatability is bad, it would not be able to redo this multiple times because the cube will move somewhere and it's not going to work. It was able to repeat it 20 times, no problem. The cube moved just a little bit from the original position. So the repeatability of this robot arm is quite impressive. And it's understandable because it uses the belts, and I suppose this is a backlash belts. So there is no much backlash in this robot arm. Perfect. It's quite easy to program, and I like that you can easily program it either in the real coordinates or in the joint coordinates, and you can mix them. So you can write one command where you specify the joint position, and in the next command you can specify, instead of joint position, you can specify the coordinates and the rotations of the end effector. Another great advantage of this robot is that you can disassemble and reassemble it. Like this you can learn how it was built. I don't want to disassemble, reassemble it completely, but I would like to see what kind of motor is over here, because it's quite small. It has a little bit of backlash, so probably the gearbox there is not the belt one. So I have no idea what is inside. That's why I'm curious what is inside. So this screw is removed from here. Let's see what is inside. And inside we have a small stepper actually. So let's try to check it from other angle. So there is a stepper, and underneath the stepper there is a small gearbox. And now the conclusion time. The robot arm is really well built. It works perfectly, and in my opinion it has a good fit for the educational robot arm. So I think this robot arm is really going to be useful for the beginners in robotics. The robot arm is rebuildable, meaning that you can disassemble, reassemble it. Like this you can learn how it works. It has a multifunctional box, this one, and this box has a lot of input-output, so you can connect multiple different sensors to this box. Not only these accessories, but many other accessories which you can build by yourself. And also all these grippers are quite good in terms that you have the electric gripper, you have the pneumatic gripper, you have the suction cup. So like this you have more or less everything what usually is used in terms of the end effector in the robotics. The software is also really good. I tried just a small portion of this software, but what I tried works really well. I found one minor bug, but I'm pretty sure that this bug is going to be resolved before this video is going to be published. I haven't tried the ROS, MATLAB or Arduino programming for this robot arm, but I assume that it should work because everything else what I tried worked quite good, and WLKATA is a well-known company for the educational robotics. So this is a great robot arm to learn the robotics. Thank you for watching this video till the end. Huge thank you to people who support me via Patreon and via YouTube channel membership. Here are their names. Thank you a lot. As usual, stay safe, good luck with your projects, and see you next time.